Triangulation is a method of measuring distance in all sorts of applications, including mapping, as well as in astronomy. So to explain, let's take a straightforward example. Here we're going to measure the distance some trees on the other side of this broad and raging torrent. The other bank is inaccessible. We can't measure directly, so we're going to use this method of triangulation. Using a 90-degree set square, one side of which we aim towards the trees, and the other side we align down the baseline, which we have made, in this case, a convenient 10 meters long. And then we move to the other end of the baseline and align one arm of the set square along that, and the other arm directly towards the trees to which we're measuring. The new angle on the set square has to be measured. Looking from one direction, it's 84 degrees, and from another, 83 degrees, so we'll settle on 83.5 degrees. So we've measured two angles of a triangle, one side of which includes the baseline, and one side of which includes the distance we want to measure. If we set that out on a piece of paper, you can see that we know one side and two angles of this triangle. By subtraction from 180 degrees, we can calculate the third angle, 6.5 degrees, and from that we can calculate the unknown length, the distance we want, which is marked as x in this diagram. If we use the relationship tan theta is opposite over adjacent, then using the smallest angle, tan 6.5 degrees is opposite, which is 10 over x. If we rearrange that, then x equals 10 over the tangent of 6.5 degrees, which is 10 over 0.114, which in turn equals 88 meters. In order to work out a much larger distance, such as that of the moon, we need a much larger baseline. That can still be taken from 2 points on the Earth, providing the observations are made at exactly the same time. And the calculation can be done in a similar way. For more distant objects, such as stars, we need a far larger baseline. And in that case, we use the orbit of the Earth. An observation is made of a particular star from a point on the Earth's surface, and then 6 months later, when the Earth is on the opposite side of its orbit, the same star is examined. Against a background of very distant stars, that star that we are looking at will appear to shift. From that movement, we can work out the angle marked at the tip of this triangle. Using the baseline, which is the radius of the orbit of the Earth, 1 astronomical unit, we can do the calculation in exactly the same way as before to find how far the star is away. These angles are likely to be very tiny, a fraction of a second of a degree. And a second of a degree is a 60th of a minute, and a minute is a 60th of 1 degree. Thank you for watching. Notes available on the website.